The second category of compounds we're going to talk about are called covalent compounds, and they are formed between two nonmetals. Tell me, review back real quickly. What's an ionic compound made of? Two charges. Okay, an ionic compound is made up of a metal and a nonmetal, right? Or a cation and an anion. And ionic compounds need to be neutral. Now, in a covalent compound, it's formed between two nonmetals. What are the charges on nonmetals? All negative. So is there any way our compound can be neutral? No. All right, so the way these work is that now instead of trading electrons, like what happens in an ionic compound, covalent compounds share electrons, and so the charges now are a little bit more insignificant, okay? They end up sharing electrons, and so the way they bond allows these two negative things to come together. So, in a covalent compound, they follow a different set of rules for naming. In a covalent compound, the first element in the formula is named first using the full element name. So the first element in a covalent compound gets to keep its name. Okay, so we would go back to using oxygen or nitrogen or whatever it might be if that element comes first. The second element always ends in IDE. Okay, first element keeps its name. Second element ends in IDE. Okay, the second element always gets a prefix. Always, always, always. And I'll show you what those prefixes are in just a minute, but these are going to be mono, di, tri, tetra, all that kind of stuff, okay? So those are the prefixes that we use. Prefixes are used exclusively in covalent compounds. So these types of compounds, these are the only ones that use the prefixes. So I would maybe write that a little bit bigger over here somewhere, wherever you need to, but covalent compounds are the only types of category of compounds that use the prefixes. All right. The first element only gets a prefix if there is more than one of that element. So I'm going to give you an example here to help you kind of remember this rule. Tell me what the name of this compound is. Carbon dioxide. Carbon dioxide. You just applied all of these rules in a compound you already know. Carbon dioxide. So let's think about it again. Carbon and oxygen are both nonmetals. That's how they go together. Carbon gets to keep its regular name, right? And oxide ends in IDE. And it has a prefix. So carbon dioxide, right? It ends in IDE. It has the prefix. Carbon does not have a prefix because there is not more than one of them. We don't call it monocarbon dioxide, right? It's just carbon dioxide. All right, so here are the prefixes. And I think I left that table in your notes for you to have, okay? Those are ones that you'll need to know. When I say need to know them, you'll get familiar with them as we use them. I would say up to tetra, you need to be really comfortable with. After that, you can take a pretty good guess because they're just normal numerical prefixes. Tetra, I think, is the only one that maybe is a little bit new for us. Usually you think four, you think quad or something like that, but tetra is the chemistry one. Otherwise, I think all the prefixes are pretty well familiar with. Okay. So we already said we don't have to use concern when we're talking about the charges because they're both going to be negative, so they're not going to balance, right? We're not concerned with that. And we do use the prefixes for covalent. So let's just do some practice here. With covalent compounds, there is no crisscross. There's nothing that goes with crisscross. You just read it exactly as is shown. So if I have one like says this, N2O3, we're not having to crisscross. We're looking at the charges. All we're doing is we're calling this dinitrogen trioxide. Very good. No crisscross, no reversal. It's just reading it as it is, okay? So if I asked you to write the chemical formula for sulfur tetrachloride, what would you say?
Where's sulfur?
What would you say?
SCl4.
SCl4. That's it, right? No crisscrossing of the charges, no anything. You just read it as is. So the prefixes might be the thing that takes you the second here to just kind of know what our prefixes are. But for the most part, covalent compound naming is significantly easier than ionic compound naming. Okay. The trick here is coming into identifying, is it ionic or is it covalent? That's the first thing you've got to identify. Is it made between a metal and a nonmetal? Or is it made between two nonmetals? Because that determines what set of rules you use to name it. Okay, so you've got to determine, is it ionic or is it covalent first?
Do you capitalize the name of the element?
Nope. It's not that big of a deal. When we write out the name, it's not like it has to be capitalized. In the compound itself, right, whenever we write an element, the first letter is always capital, second letter is always lowercase, because that tells us if we've got a new element coming, right? We have to be able to understand the difference between CO as carbon monoxide and CO as cobalt, right? We need to be able to differentiate that. An uppercase letter tells us that a new element has started, okay? So make sure that you're careful with that. But if I was going to name... if I was going to name this one listed right here, what would it be? Carbon monoxide. So I'm going to give you one extra little rule here for naming. And this is really just a pronunciation and spelling rule. If the element starts with a vowel, drop the O or A from the prefix. So let me give you an example of that. If the element starts with an A or a vowel, you drop the O or the A. So that's why it's not called monoxide, right? It's called monoxide. And it's really just about the pronunciation and the speech of that. So if we have this, N2O5, we would call this dinitrogen pentoxide, not pentaoxide. Okay? It's not the end of the world, right? If that A or the O gets left on, but it just makes the flow a little bit better. Okay? So that's just more of a pronunciation type rule. Okay? So we have questions about identifying the difference between ionic and covalent? Feels like another language. It makes you feel good when you get it. Okay.
It reminds me of some